Jai Hind everyone. I am Anshul Kumar Panchbhaiya. Today we are going to discuss the topic named as Design Against Fluctuating Load, and it is one of the important topic in machine design, and it has been taught in 6th semester in B.Tech Mechanical Engineering AKTU. Now let us begin. First of all, we must know that what is a static load and how fluctuating load is different from static load. As we can see in this figure, if we talk about static load, you can see a graph is shown between stress and time, and here a stress is being applied constantly, means the stress is constant with respect to time. This type of condition comes under static load. Suppose if the load is not changing with respect to time, means if now the weight you measure, it's the load you measure is, suppose it's 6 Newton, and after 1 hour you measure it again it is 6 Newton. That means change of time is there, but the load is constant, and with respect to that stress is also constant. This is known as the constant stress, and this condition is known as static load. But whenever the load is continuously increasing then decreasing, like we can say in case of shocker in automobiles, here the load is suddenly increasing then decreasing, and you can see here the curve also. This curve is again between the stress and time. Now in this curve you can see that the load is continuously increasing and then it is decreasing. See, this is increasing part, then decreasing, then again increasing, then decreasing. That means the stress is not constant with respect to time. This type of loading condition comes under fluctuating load, and our concern is to discuss this part, that is design against fluctuating load. Now here, if we need to move further, then we need to understand that in fluctuating load there will be two stresses. One will be known as the maximum stress and the other will be known as the minimum stress. Now, as you can see in this figure, from minimum it is reaching a maximum value, then coming again to minimum, then again maximum, and then again minimum. So this first portion, this graph, we renamed it as one cycle. This is the one cycle completion. Then other is another one cycle. Now there are two terms also mentioned here, sigma A and sigma M. What are these? These we are going to discuss now. First of all, we need to understand, before going through fluctuating load, we need to understand some parameters. These parameters, first of all, first parameter is mean stress, that is sigma M. This mean stress is also known as average stress or center line of sigma max and sigma minimum. In this slide you can see there is a sigma max point and there is a sigma minimum point. Then the average of these two stresses will be known as mean stress. Now you can see here sigma max plus sigma minimum divided by 2. Now keep this thing in mind, students, that whenever you are putting the value of sigma max and sigma minimum with sign, that means you have to put it with sign, means for tensile you need positive sign, and if there is negative sign then the stress is compressive. Means suppose we have sigma max equal to 100 megapascal and we have sigma minimum equal to minus 50 megapascal. Then if we talk about the average, yani sigma mean, that it will be 100 plus, with sign you need to put it, divide by 2. Then the value will be around 25 megapascal. So this is the mean stress, means the average stress. Average stress. Now, if we come to the next point, that is sigma A, it has been clearly mentioned that how much stress is fluctuating above or below the center line. If we see this figure, now you can see here, this is the line of sigma m, that is the mean stress. Now, if I take this as a reference point, then the maximum stress point is this and minimum stress point is this. So this is the fluctuation from reference line. And this reference line is nothing, this is sigma m. So this fluctuation is known as amplitude stress. This fluctuation is known as amplitude stress. And if we talk about the amplitude stress, we can easily see from this figure, I can easily write, so you can see here, this from this point to this point is sigma m. So you can write sigma m, and if you add sigma a, sigma m and sigma a will be written as sigma maximum. It can be written sigma m plus sigma a, total sigma maximum. Now if we see what is written here, sigma a plus sigma m, this equation can be rewritten as this also, sigma a plus sigma m equal to sigma maximum. Now this can be arranged like this, and we know this sigma m is nothing, it is like this from equation written above. On solving you get sigma a is equal to sigma max minus sigma minimum by 2. That means the difference between the mean stress and the amplitude stress formula is the sign. In mean we have the plus sign, in amplitude we have the minus sign. So this is the difference. This is the mean stress, this is amplitude stress. Now if we talk about, there is another term we should know, that is the stress ratio. It is nothing, it is, first of all, it is represented by capital R, and it is defined as the ratio of minimum stress to the maximum stress. This is known as stress ratio. These formulas we are going to use when we are solving the numericals. We will be requiring these formulas. Then another formula, another term is amplitude ratio. What is an amplitude ratio? It is nothing. Amplitude ratio is defined as the ratio of amplitude stress to the mean stress. Now we know this sigma A is nothing. We have discussed sigma max minus sigma minimum divided by 2. And this sigma mean is nothing. Sigma max plus sigma minimum divided by 2. These two get deducted. If you move further, you can write sigma max, you can take it as common, and you can write sigma minimum upon sigma maximum. Again in the denominator, if you take sigma maximum common, you can write 1 minus sigma minimum to sigma maximum. These sigma max got deducted, and we know, just we have discussed, the sigma minimum upon sigma maximum is capital R. So this will be written as 1 minus R upon 1 plus R. So we have written this formula. So these are the 4 important parameters we must know while discussing design against fluctuating load. And fluctuating load is nothing like that. It is shown in the figure. Load increasing, then decreasing, increasing, then decreasing. This is a fluctuating load. For example, the shock absorber or the shockers used in automobiles. These are the 4 terms we have discussed now. Now, if we move further, as we know, we are discussing the design against fluctuating load. Now, from design point of view, 2 parameters in these 4 parameters two parameters, first and second. These two parameters are very important. These two parameters are very important parameters. Now, we need, for moving further, before moving further, we need to understand some more important definition, because of important terms we need to understand for these design of fluctuating, it's a design against fluctuating load. What are those terms? First is the repeated stress. We need to understand this term, repeated stress. Now, if you see what we have written, what I have written the definition, stress repeated from 0 to maximum. Stress repeated. Suppose this is a diagram, stress versus time. This is the origin, 0 to maximum. 0 to maximum. Again 0. 0 to maximum. Like you know, when we open a car, opening and closing of a car door comes under a repeated stress. Loading and unloading is done in the car door. You open, maximum, then 0. Maximum, 0. That means if we see this figure, we can see here sigma max and sigma minimum is shown here. But here, sigma minimum will always be 0. Sigma minimum will always be 0. If sigma minimum is always be 0, then as per our formula of sigma m, we know sigma m is equal to sigma max plus sigma minimum divided by 2. Now, if we talk about sigma a, we know sigma max minus sigma minimum divided by 2. Now, these two terms are 0 from this formula, from this discussion. That means sigma m will be sigma max by 2 and sigma a again sigma max by 2. That means mean stress and amplitude stress are same. Now, from this definition, we came to a conclusion that whenever there is a repeated stress, then we have amplitude stress always equal to the mean stress. If I summarize this, I can say repeated stress is nothing. The stress repeated from 0 to maximum. From 0 to maximum. That means practical example is just like an opening and closing of a car door. It's a loading and unloading. Now, here the minimum stress will always be 0. That means sigma m and sigma a both will be equivalent. We have seen it. For the repeated stress, we will always say, sir, repeated stress is nothing. It is whenever the amplitude stress is always equal to the mean stress, we are talking about the repeated stress. Is it clear? Yeah? Then we can move further. Then there is another important term we need to understand, that is known as completely reverse stress. One of the very important terms for understanding the designing of fluctuating load. Very important term. Now, what is a completely reverse stress? See, we have taken a diagram here. Again, the diagram is between the stress versus time. Two stresses are shown here. Mean stress is shown 0. You can see sigma m is 0. Now, what is a completely reverse stress? Where the stress, where sigma max is always equal to sigma minimum in magnitude. Magnitude will always be same, but direction different. That is known as completely reverse stress. You can see here in figure, sigma maximum is 100, sigma minimum is again 100, but in sigma minimum I have used minus sign, that is for the compressive nature, and plus sign for the tensile nature. Now you can see this condition means magnitude is same, but the direction is different. That is known as the completely reverse stress condition. Now, if you see in this figure, I have shown sigma max and sigma max minus in sign. Actually, this is sigma minimum. Sigma minimum means minus sigma max. Now, if I go further, I will write sigma mean. The formula is this. And we know these two terms are equivalent with opposite in direction. That means sigma mean will always be equal to 0. And amplitude stress will always be equal to sigma max. That means we came to a conclusion that they come in a completely reverse stress, we always have mean stress equal to 0. Means in completely reverse stress, we can say mean stress will always be equal to 0. And amplitude stress will always be equal to the maximum stress. What is an example? We can say an axle subjected to bending. See, practical example of completely reversal. Let us say, how we understand? Let us say we have an axle. Axle, it is just like a shaft, but axle just rotates. Axle only rotates, which is simply rotating but not subjecting to torque. As you can see, it has been shown here. Rotating, and there is a load acting there. This is the after bending. Now, if we move further, let us say the cross section of the specimen is circular in cross section. Now, if we see, suppose the rotation is like this, shown here. Now, if we are at point A, this is the neutral axis. At point A, this is the maximum condition. If we rotate it further, we reach to P dash, then again at P dash, it will be 0 because at neutral axis, the stresses are 0. If we move further, P double dash, then again a maximum condition, but direction is opposite. Then if we rotate it back, then we again got the 0 position. Means now point P is continuously rotating. The stress of the particle P is fluctuating from sigma max to minus sigma max. Means P is fluctuating from here is sigma max. Here it is minus sigma max. Here it is 0. So this is the example of completely reverse stress. Means you have maximum stress, same amount of stress at two different points, opposite point, but the direction is opposite. So this is the example of completely reverse stress. So what are the conclusion? The conclusion is, if we talk about the repeated stress, I will say the stress where sigma mean is always equal to sigma A. Means amplitude stress is always equal to mean stress. This is the repeated stress. If we talk about completely reverse stress, I will say the stress where the magnitude of maximum and minimum stress will be same, but direction will be opposite. That is known as completely reverse stress. And here also, here the sigma m, that is mean stress, will always be equal to 0. This is the conclusion. Now, what we have studied right till now, we have seen what is a fluctuating load variation. We have seen, we have gone through some important parameters, like we have seen, we have gone through sigma mean, then amplitude stress, and then stress ratio, then amplitude ratio, and then again two important parameters. And before that, I've told that for designing, we need sigma m and sigma a as a major parameters to be discussed. Then we have gone through completely reverse stress and repeated stress. In repeated stress, sigma a equal to sigma m, and in completely reverse stress, sigma m equal to 0. Now, if we move further, what we are going to see, how material fails under fluctuating stress, because we are discussing the topic named as design against fluctuating load. And if the design is against the fluctuating load, we must know how a material fails under fluctuating stress. Now, before that, let us see how a material fails in design against static load. Under static load, material fails due to yielding or due to fracture. In static load, material will fail due to yielding or due to fracture. I mention it here, yielding and fracture. Whenever we are talking about yielding, means that at that case, sigma maximum is nothing, it is SYT, material failing due to yield strength in tension. And if we talk about the fracture, the material fails due to sigma maximum is nothing, it is equal to SUT, means SYT, yield strength in tension, and SUT, ultimate stress, are the two designing parameters and two failure criteria for static load failure. But if we talk about fluctuating load, which is our concern, what I have written, under fluctuating load, material fails due to fatigue. The failure criteria is fatigue. Means if we differentiate it from static, in static the failure criteria are SYT or SUT, you can say yielding and fracture. But here in fluctuating load, the material failure is due to fatigue. Now, what is fatigue? If you need to understand, let us take an example. Suppose we want to break a metal body. Suppose we want to break a metal body made of steel. We can take steel as an example. Using a static load. Means using static load. Means load applied only once. You can apply load only once. Now, then, if we need to fail the material by static loading, and the load will be applied only once, then we need to apply either SUT of steel, because this is a fracture strength, and we know that in static load the material failed due to fracture or yielding. If we need to break the steel, we need to apply the strength equal to SUT, but SUT of steel is very high. But and it won't be possible for us to apply that high strength at only once. What we can do? Still we want to break it. Then we can break it using fluctuating load. Then what we do? We will not apply the load equal to SYT or SUT. We can break the material in yielding what I said sigma max equal to SYT or sigma max equal to SUT when we are talking about static load. But in fluctuating, we can break it less than SYT or SUT. Still the material can be braked. But we need to apply the continuous load. Like if you want to break the wire, you can apply the wire. What you do? You just apply a continuous load. And this load is very much lesser than the ultimate load or a yielding load. Very much less than SYT or SUT. And still you are able to break that. That repeated load is known as fluctuating load. And this will be applied for some number of cycles. Means if you are breaking a wire, you are applying like this. Breaking a wire, and you are applying that load for some number of cycles. And this is known as fatigue failure. Means material is again breaking. You are able to break the material, but the strength is very much less than the SYT and SUT. Very much less. And if it is less, that means you are applying this stress for certain number of cycles. You are applying this stress for certain number of cycles. This type of failure is known as fatigue failure. Applying the stress lesser than SYT or SUT and lesser than SYT and SUT and for certain number of cycles is known as the fatigue failure. I hope you have understood the concept of fatigue failure. Thank you.